Not every reaction falls in the category of double displacement or metathesis. Another very common type of chemical reaction is an oxidation reduction reaction. Which is usually simplified to be called just the redox reaction. And there are three types of redox reactions for you to be aware of. Some of these you've already seen before. For example, a combustion reaction. Combustion just means reaction with oxygen. And a reaction with oxygen is where the name oxidation comes from. So, for example, methane reacts with oxygen and it forms carbon dioxide and water. So this could be classified as either a combustion reaction or it could be classified as an oxidation reduction reaction. You can also see a transfer of electrons. For example, a metal like copper cation can be reacted with solid zinc and form zinc cation and solid copper. So whenever you see the charge being changed from one metal to another, this means electrons were transferred, and that's also a type of redox reaction. And then the last type is another one that you've already seen, metal reacting with nonmetal. So for example, if I told you lithium reacts with fluorine. Fluorine is one of the diatomic gases, so it's F2 instead of just F. You already know how to do a metal with a nonmetal. You learned this when we started doing the crisscross. Lithium's a +1, fluorine's a -1, so lithium fluoride, LiF, and we need a coefficient of 2 to make that balanced. Another way to look at reactions is by looking at how the atoms are rearranged. We've already seen the double displacement reaction. So we know the general form of this is we have an ionic compound. So we have a cation and an anion reacting with another ionic compound. So I'm just calling these A, B, and C, D. We know cation is always first, anion is second. Cation is first, anion is second. So when we write the products, we're going to pair up the positive A with the negative D. And when I'm showing it in this general form, I'm not putting the subscripts because I don't know exactly what the charges are. So the general form is we have the new product AD and CB. That's a double displacement reaction, but you can also have a single displacement reaction. So in this example, we have one element A reacting with a compound BC, and basically the A pushes the B out of the way, and now we have a product. A is paired up with C, and B is on its own. So as an example, iron reacts with sulfuric acid, and now the iron pairs up with the sulfate, and the hydrogen is on its own, and hydrogen is a gas. This is not a single displacement, is not a reaction that you'll have to predict the way you are expected to be able to predict double displacement products. And then we have two other categories, synthesis and decomposition. Synthesis means we're making something. So we take two small molecules or elements and we put them together to make a larger one. So for example, aluminum can react with sulfur and make aluminum sulfide, and we need to have this balanced. So this is a synthesis reaction. It could also be classified as a redox reaction because we have a metal reacting with a nonmetal to make a compound. Decomposition is basically the reverse of synthesis. We take a big molecule and we break it down into smaller pieces. For example, if you're given this reaction, larger molecule on the left breaks down into two smaller pieces on the right. So that's the opposite of synthesis. That's a decomposition reaction.